Right, so here's a go at creating a model of an epidemic spreading throughout a population using Python mode in processing. Notice please I'm using processing here. This is not raw Python. I'm getting processing to do a lot of the heavy lifting around displaying things on a screen. So we've got a blank processing window here, which is really very threatening at the moment. But let's see what we're going to do. So there's 3 stages to what I have in mind here. So let's just note what those are. I'm trying to find the hash symbol on my keyboard. There we go, for comments. So firstly, what I want to do is get a ball bouncing around the screen. Then we're going to get lots of balls bouncing around the screen. And then we're going to get patients. Or people, I suppose. They're not patients yet. People moving and infecting each other. Okay, so that's the plan of action there. So we're starting with something very simple, and then we'll get a little bit more complicated. And there's plenty more that we could do after that, but we'll come back to that later. Okay, so I'm going to define a couple of things here right at the start. So I'm going to say we're going to work on a 400 dot width, and we're going to work on a 400 pixel height in here. We are going to need our standard processing setup loops. So I'm going to define my setup script here as going to be creating a screen of size, whatever that width is and whatever that height is. We may as well fill that background with some sort of grey colour. Let's go for just 32. There. Okay, it's going to collapse when we run this. Watch. Oh, maybe it doesn't. Yep. Oh, it's definitely not. Maybe it has worked. Okay, it seems to have taken the W and the H there. I was expecting to have to declare those as globals. Sorry, it's running outside. So it does seem to have set up. That's nice. I was expecting to have to declare those as global width and height. Isn't it lovely when it works, even when it's not been programmed to? That's great. Okay, we've got our standard draw loop, but there's nothing to draw at the moment. We could play around with that, but let's just get a draw loop in there. So defining draw, and what we're going to do is let's just draw an ellipse. Center on, let's do 200 at radius 10 and 10. I think that's the right syntax. Let's see, there we go. We've got a dot right in the middle of the screen. I'm happy with that. So that's the processing stuff. What we've got to do now is just get this ball working. Oh, as simple as that. So what I'm going to do is treat my ball as an object, and an object of the class balls, or an object of the class ball, I should say. So let's create a class of ball objects. Notice the capital letter, which is standard in Python for a class name, and that's of the type object, or of the superclass object, which is all of the possible objects, or the generic things which apply to all objects. Now I think I will need to pass that, my width and my height, as global variables. So I'm going to be referring to those. We have the constructor method, the init dada init method, running on these balls. So what are we going to need for each ball that we create? Let's get this constructor up and running. We're going to pass it the x position of where the ball starts, the y position of where the ball starts. I want to also pass it a velocity in the x direction and a velocity in the y direction. Those of you with mathematical background will know that we're looking at a vector here. Processing does have vector as a type, or possibly as a class. But we're not going to be using that. We're just going to use the individual components of that. So that's an x coordinate, y coordinate, and then velocity in both of those directions. Okay, so for a particular ball object, we're going to initialize that the self object, the particular ball, as having an x position as equal to whatever we passed it there. We're going to say its y coordinate is equal to whatever we pass it there. We're going to say its velocity component is equal to Vx bar, and self dot Vy is equal to Vy bar. This allows me to initialize it by passing it 4 parameters. And that should create a ball object. We can just do that. It's not going to do anything because we've got no code at the moment, but I can say my first ball, ball1, is equal to ball, and then let's pass that some parameters. Let's say that's at 200, 200, moving with velocity 5 to the left, 5 up, and hopefully at this point it should not throw any error messages. It threw an error message. Init takes exactly 4 objects, 5 objects, 4 given, and I of course forgot that it's initializing that particular ball. So let's try that again. And nothing's happened. That's not the ball, that's still just the ellipse that I drew. Okay, so we've initialized the ball. Now let's get it to display the ball. So let's define a new method called display, which takes that particular ball and displays it on screen. And what we're going to, oops, colon missing. What we're going to ask it to do is to do pretty much what we've done already. Let's draw that as an ellipse. And let's set the fill up as, oh, I don't know, middle of grey, 128, 27 strictly, I guess. I just put a random colon in there, and then an ellipse, not always at 200. Let's change the ellipse coordinate. What we've got, so we've got x bar, we've got self.x, the x coordinate of this particular ball, self.y, and then we've got our 10 by 10 and 10 radius, the ellipse. Okay, so now rather than drawing a standard ellipse, let's draw this particular ball. So I do ball1 and then call in the method display. For that, it's treated as a function or a procedure, I should say, on that. So we pass it no parameters. The ball1 is the self parameter it's referring to. Okay, because this will look exactly the same as the previous one, let's change the position of that to 100 dots across and 300 dots in the bottom left quadrant of the display. Whoa! Something. Oh, I put a comma. There we go. There you go. So we've got a grey ball now towards the bottom left of the display. How exciting is that? Okay, so we can create, we've got input and output working. We've got no actual processing working. So let's have the ball move now. So again, defining a method, which is going to be called move on this particular ball. And what we're going to do here is increase the x coordinate. So self.x increases by whatever the self.vx is. So we change the position by its velocity. And we do the same thing in the y direction, self.y plus equals self.vy, and Hidori. We now also need to do some sort of collision detection for the edge of the screen here. Actually, I'm going to do that before we update the x and y coordinates. So what we want is if self.x is less than 0, or self.x is greater than width, which is why I needed to pass it the width of the screen as a global, then change the velocity. So the velocity becomes the negative of whatever velocity was. So Vx is multiplied by self.Vx is multiplied by -1. I also have an if, it's not an else if because it's two separate conditions. Self y is less than 0 or self y is greater than height, then self y we multiply by -1. Okay, so we're checking if it's got reached the edge of the screen. If so, we change that the velocity vectors in that direction. Then we update the coordinates with that new thing. That looks fine. So see, okay. And then we're going to do that each time we go around the draw loop for the ball. So I'm going to do ball1.move each time we go around that draw loop. Oh, and I ought to be resetting the screen every time we go around. I think I've got that already. Interesting. No, because we had a static ball before. Background, and that's. We went for a nice little grade, 32, like that. Background 32. Okay. Oh, and I'm just going to mess with one of these components because that otherwise gets it directly on the diagram. Effect there. Okay, we've almost certainly made some mistakes. Let's see what it says. No! Perfect coding. I could watch this all day. Yay, it's like playing squash. Well, it's like playing billiards with an incredibly smooth billiard table. You might want. I mean, we've got physics going on there. On a flat surface, you could, once you've got this, then adding in the whole of the rest of Newtonian dynamics is just a matter of some code. Really it is, folks. I'll leave that as an exercise, as they say. So I have got a ball moving down around the screen. I want a tick symbol, but, yes is good enough. Actually, an ecstatic yes. Get lots of balls bouncing around the screen. Oh my goodness, how on earth are we going to do that? Well, this is the beauty of the thing, okay? Because we have a class here. We can create lots of objects which belong to this class. So let's set up number of balls equals, 10 to be going on with. And then all we need do is initiate each of those balls in turn. So I'm going to replace ball 1 here with for I in range number of, I'm so used to code completion in editors, number of balls. Then what are we going to do? We're going to say that, we need an array up here, don't we? So we're going to say balls equals an empty array, and then balls dot append a new ball. So we're going to create a new ball. We ought to create these with some sort of randomness going on here. So let's do random width for the x coordinate. Let's do random h for the height coordinate. We can do the same thing for vx. So random -10 to 10, and the same for vy, random -10 to 10. And that should create 10 random balls. So the only other thing is then inside our draw loop, we need to display each of those balls in turn. So for I can copy this, can't I? For I in range number of balls, ball I moves and ball I gets displayed. And do you not think that's an amazingly economical method? As I say, we've got this whole new class of things, yeah, these balls, and now we can so we can create lots of these. Each of these has the same method. Each of them has their own particular data, their own position, their own velocity. And with a little bit of luck, we've not made any mistakes in the coding there, so we should get 10 balls bouncing on the screen. No! Okay, maybe there's an unclosed parenthesis somewhere. Okay. Maybe there is an unclosed parenthesis somewhere. Okay. The line probably indented. Yes, it does. Of course it does. You spotted that, didn't you? Right. Okay. The name ball is not defined. No, because it should be a capital letter. A global name ball. Okay, yes, because I'm referring to Eye of the Balls. That seems like it's a line from Star Trek. There we go. Okay, so with what was that, like 4 mistakes in the coding? We now have 10 balls bouncing around the screen. I'm not going to watch that all day. They're not colliding with one another, which billiard balls obviously would. You want 100 balls bouncing around the screen? We can do 100 balls bouncing around the screen. My God, it's gone crazy. This one's a really slow one. Okay. Oh, come on. You want to see it, don't you? You definitely want to see it. 1,000 balls bouncing around the screen? I think that's too much. That really is too much. Oh, and notice the edge to those. So in my setup, I might actually do something about no stroke. Okay, let's take this back to a more sensible number. Right. What next? So I can confidently say, yes, that took a little while to correct. Get people moving and infecting each other. So this is the big stuff. Everything so far is really just preliminary. What we're going to do now is deal with people rather than just balls moving around the screen. So some of the heavy lifting, or some of the light lifting, I should say, is already done because we have this ball object, and a person we're going to treat as if they were a ball. So what I want to do is create a person object, but the person object is going to be based on the existing ball object. We call this inheritance in object-oriented programming. So we're able to take the properties and methods which we've defined for one class of objects and apply that to another class of objects. Think of it as a class inside that class. So people are just a special type of ball that has some additional properties to them. Okay, so we have person ball of type ball, and we're going to leave things as they are for the moment. So what I want to do here is initialize a new person, and we're self, and we've got all of those parameters there, x, y, vx, and vy, and then I've got this super command which allows me to inherit things from another class. So I can initialize this as an object within that the higher up class of ball object. So what we do here, I'm just checking I've got the syntax right, is super of type, it's super of type person. The parent class of the person, which is the ball, and then apply the initialization method to that. So this particular person, then we do the initialization. So that's looking up a level. So we look at the superclass of this particular person, which is a ball, and we initialize that ball, and we pass that its parameters, which are x bar, y bar, vx bar, and vy bar. That's all we're doing at the moment. So we're creating a type, a subclass of type ball called person, and in order to create a new person, what we do is go off and create a new ball with exactly the same properties. So that, hopefully, let's just run the code. It's not actually going to check that. That's just exactly as it was, which is absolutely fine for me. Okay, what we're going to do next, instead of creating 10 balls, we're going to create 10 people. So my people are an empty list, and the number of people is what we're going to refer to earlier, and then I append to people a new person, blah, 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 and that creates that, and then number of people here, and then people I, and people display. Okay, so, and then we've got Now, you may be worried at this point because I've not defined any move or display method on any of my persons. Sorry, on a person. So I'm creating a new person object here, adding it onto my list of people, but I've not got a method for move or display defined in the person class. That's the joy of inheritance, that it says if there isn't a method with that name in the class, then look up to the parent class and use that class's method for it. So again, I'm going to have made syntax errors here, but let's see. Oh, no, I didn't. Isn't that amazing? So nothing has changed. That's exactly as it was, except these aren't balls. They may look like balls to you, but these are in fact now people. How cool is that? Okay. So, in fact, we're going to create people in a slightly different way, because what I want to do is to be able to refer to each person by ID number. Now, balls are all exactly the same. People are going to be slightly different. So I'm going to pass it an ID number. I'm also going to need the status of each person. So that's whether they're infected or unexposed at the moment. So I'm passing it a couple of extra parameters there. The XY, VX and VY are still passed to the superclass, the ball class, but we're going to initialize the ID number for this particular person to be equal to whatever we pass it, and we're going to initialize the status of this particular person to be whatever we pass it. Good. Okay, now when we initialize a person rather than a ball, we have to pass it those numbers, or parameters, so we're going to pass it the number that we have in the iterator here, and we're going to start off with all of them uninfected. So that's my status, which is unexposed to the virus. Okay, again, that should work exactly as is. Says he, nope. Okay, takes exactly 6 arguments, 7 given. Okay, yeah, I made a typo. There we go. Okay, so these are definitely people. They've each got ID numbers. They've each got a particular status attached to them. We're not doing anything with that at the moment. Okay, we are going to infect patient 0 at this point. So I'm going to say that people, and who better for patient 0 than iterator value 0, status equals infected. That looks okay. Okay, so it creates all of those as unexposed and then changes the status of patient 0 to be infected. Yeah, so we can't tell the difference at the moment. So what I'm going to do is take my current the display method for the ball, and change that when it's a person that we're displaying here. So I'm going to have now a new display method, which just applies to people, not to balls generally. And what we're going to do is color that in according to its status. So if self dot status equals unexposed, then we can go for our lovely mid-gray at the moment. Elif, I'm not going to do else because we might want to add other ones in here later. If status is infected, then set the fill to be a really dangerous looking bright red. Okay, and that should then fill in one of those ellipses, in fact ellipse 0, with the right colour. So that's my display method, not for balls in general, which I've not changed. This is for people, which are a type of ball at the moment. And there's patient 0 zooming around the screen, but thankfully not inoculating anybody else because they're washing their hands, which is really very important. Okay, so we've got that. We really ought to deal with infection, though. What if they didn't wash their hands? What if nobody washed their hands? Well, infection is going to happen when 2 of these balls collide, and this is tricky. Okay, so what we have to do here is to be able to refer to all of the other people. So I'm going to need to pass person class the global of all of my people that I've created. There are other ways of doing that, but this one seems okay. I'm now going to create a new method for people, which is going to be collide, and that's going to just apply to whichever ball we call it on. Right, so what we're going to do is test whether one ball is in the same position as any of the other balls that come after it in our list. That should check collisions between each of them once only in every screen refresh. A collision between two balls means that the centres of the balls are less than double the radius of the two balls. So if you've got balls of radius 10 and two of those are less than 20 units apart, then they're colliding. If they're more than 20 units apart, then there's no way they could have collided. Circles have this special property. If you drew them as squares, it would actually be more complicated, so that there's a good reason for treating people as if they were just balls. Right, so we're going to iterate across a list to check for each of these collisions in turn. So I do for I in range, and we're going to start with the ID number of the ball that we're looking at, but beyond that, so from the next ball on up to the total number of people, which I also need to pass as a global. Okay, for I in range that. All right. I'm going to work out the difference between the x coordinates, call that dx is equal to self dot x minus the other ball, so that's people I x. The difference in the y coordinates is equal to the self y minus people I dot y. Okay, so that's the difference in the y coordinates. The total distance between these you can get by applying Pythagoras' theorem. I don't know, square root sounds a plausible name to call the square root function. We're not going to use it, but that's news for later. And then we use Pythagoras' theorem by squaring both the x distance and the y distance and taking the square root of those. Okay, what actually is quicker, because square root is a computationally complex thing, is actually distance squared. And then don't worry about taking the square root. That's slightly more efficient. Okay, so I'm working out the distance or a proxy for it between each of these balls. If the distance is less than double the radius, then we're okay. So if the distance squared is less than double the radius, double the two radii squared, then we're in the same territory. So my formula here is going to be if dist squared is less than 200, remember 10 squared gives you 100, double that gives us 200, then do something. And for the time being, we're just going to log something to the console. So I'm just going to do print collision. Oh, that's a string, isn't it? Collision with from ball I with whatever ID number it's collided with. Okay, so that's just going to log something to the console when two people collide. Okay, nothing else has changed. We're not actually showing the infection there. And I'm not actually getting a console message here. That's because I've not called the collision method. So we move them, we display them between the two of those. We're going to check whether they collide or not. And there you're seeing collisions between one ball and others. So it's detecting collision, which is what we wanted. Okay, right. What we are going to do is when they collide, we want to transmit the virus from an infected to an unexposed. So if we have that, let's not worry too much about logging that to the console. We need to test whether one of the pair is infected and the other is unexposed. So there's two ways round for that. So if self.status equals infected, and the other one, which is people number I dot status is equal to unexposed, then the unexposed changes its status to people I dot status becomes infected. And you've got a similar thing going on. I can do this as another if statement. It's not the end of the world. If self-status, actually, I think I do need it as if self-status is unexposed and the other person is infected, then, sorry, I had this the wrong way around. No, I had it the right way around. Then this time it's self.status. Okay, maybe it's going to work. All right, we've already dealt with displaying infected and unexposed differently. So here we go. Oh, okay, my usual mistake. And again, because I just copied that. You're waiting to see it. In fact, there, we got our first infection. And then they're all infected, at which point we could claim some sort of herd immunity, I'm sure. Okay, that was with 10 balls. Let's just pump up the volume here. 1280 dots across, 720 dots tall. And let's put 200 of them in there together. Here we go. That's running quite slowly, isn't it? But it is running. Massive ramping up of the virus. And everybody's got it by that. Okay, so it works. We've got a virus emulator, or an epidemic emulator. Right, I'm going to stop the recording very, very soon. There are things which you might like to do at this point. So, taking this as a starting point, I'll save this code on, let's save this now. I'll save this onto Moodle so you don't have to type all of this in for yourselves, although you possibly will learn certainly something about putting double equals in there for comparison operators. If you do, there are some tasks for you here. So what about model recovery? Model, I'm sorry, this is no easy way to say this, but death. So at some point there might be a chance of death. You could model making some people stay at home, and you could model random chance of infection on contact. So what we have is a certainty. I might actually, no, there's 4 things which you could add into the model I say very easily, which you could add into the model here, which makes it a lot more authentic. And this, of course, making some people stay at home is what we're interested in at the moment. If we increase the number of people who don't move, how does that affect the spread of an epidemic? The other thing worth doing in here is, can you get it to draw a graph? Or just report the numbers. And all of that I'm not going to help you with. Well, I might. I have got a version running in P5.js, which I can possibly, don't think I've got it, up and running here. I'll give you the code for that on Moodle, so you can or indeed on YouTube, so you can have a look at what I made earlier using a slightly different version of processing. I think that's quite enough now. I'm going to stop the tape and upload this.